One of the most fascinating aspects of GCSE chemistry is the alkali metals. I used to love it when my teacher used to demonstrate these, okay? Group 1 alkali metals, so much fun. Put these babies in water and just watch the reaction happen. There's lithium, sodium, potassium, rubidium, cesium and francium now. Some questions that you might be asked are, so what is the appearance? What are the symbols? And what kind of observation did you notice? So once you've done the observation, you then probably write down about how the reaction went. Now it's important to understand that lithium, sodium and potassium, it only gets more reactive when you get down. It just gets more exciting, especially for someone like me who loves fireworks. I just love any bright light, anything like that, reactive. And I just remember lithium just fizzes around and sodium actually goes round in water and then actually shows off a bright light, you know, a bright yellow flame is produced, actually really nice. And then potassium takes it one better, he fizzes around and a lilac coloured flame is produced. Awesome. So these are some more questions that they could ask you on a worksheet, or your teacher might ask you. Now it's important that you realize that as you go down the group 1 alkali metals, they get more reactive, okay? Now when you add these metals to water, they produce hydrogen. One way you can test that is by doing you can actually test if hydrogen is produced by doing the squeaky pop test. That's one fun way of finding out. They're also alkali metals. Once I finished the reaction, I did add the universal indicator and did go purple, showing that they are alkali. Now, the reason why I made this video is that you understand why they're reactive. Why are alkali metals reactive? Now, all elements want to have a full outer shell. Unfortunately, alkali metals have one electron in the outer shell and they're desperate to lose that, okay? So they are very reactive because of that. However, if you look at lithium and potassium is far more reactive than lithium. Why? If you look at the distance between the nucleus and the further away electron, lithium has control over that electron. It's only 2 electron shells away. So it's got control of it. It's a bit like me. If I'm a teacher, the students sitting on the first bench, I have control over them. However, them students way at the back, I don't know what they're doing and I have less control over them. That's exactly the relationship between the nucleus, the positive nucleus, because there are protons in the nucleus and the negative electron. Now if you look at potassium, its electron is so far away, the distance is so far and therefore has less control and there is less electrostatic force. And that's one of the major reasons why potassium is far more reactive, because it doesn't have much control over the electron, which is much further away. Now these are typical questions in your exam that you could be asked. State the name. They could also ask you what is the gas produced. They could also ask you that if you were to ask rubidium, if you were to put rubidium in water, how would that reaction occur? It's important that we don't have rubidium in school, it's too dangerous. But because rubidium is below potassium, the reaction would be even more fierce. And which gas is produced? We already said hydrogen. Now it is important to understand that. It is important to understand that hydrogen is produced. It's important to understand that the more lower you get, the more reactive they become. And that's completely evident, because if you put rubidium in water, it'll be even more exciting.